Welcome students to one of the most important chapters in J mathematics, that is functions. Its importance lies not only in as a separate as topic, but also as an underlying principle of calculus. And I'm also as a very important mathematical tool. In this first video, we'll be looking at a function as a special kind of relation. And let us look at a simple relation between two sets A and B, and this arrow indicates arrow from A ending at B indicates that there's a function f. It's from A to B. It's the notation is like that. Arrow starting from A and ending at B. That's a function from set A to set B, and let both the sets contain two elements. It's A containing elements A1 and A2, B containing B1 and B2. So it's a very simple format. Then on what parameters can you call this particular relation a function? That's a key point of this video. So the important point is that what relation can be called a proper function. So that's the point which we will be looking at in this particular video. And for that, for a particular relation to be called a theoretically right function, two points ought to be correct. Two rules ought to be followed. The first rule is that now we are dealing with the simple relation which was just mentioned. That's a relation from A to B, and the first point to be noted is that all elements of set A should participate in the function. So that's the first point, and so that's the first point. The second point is that the second point is a continuation of the first point, and now this participation should be in such a manner that an element of set A should not have two images in set B. It simply means that a single element of set A shouldn't be having two. It shouldn't be pairing up with two components of set B. For example, in the previous case, the ordered pairs like A1, B1 and A1, B2 is not allowed. That's the meaning of it. Let us look at three simple cases to drive home the point. And dealing with this, the same example, that is, you have two sets A and B and function 1. So you have the elements A1, A2 and elements of set B1, B2, and here A is pairing up with B1 and B2 to form the ordered pairs, and the second element of set A2 is missing in the function. So here the ordered pairs are naturally A1, B1 and A1, B2. Now the point is that, as already told, such a thing is not allowed because we know that a single element of A can have only a single B image. So two images in set B is not allowed, and more than that, the second element of A is not participating in the function. It's because of these 2 points. It simply means that F1 is not actually a proper function. Now let us look at a second case. That's where the linking the idea is quite reverse in the sense. So you have sets A and B. You have a function between them. It's F2, and here A on A2, B on B2. Here the interesting point is that A on B on is a first ordered pair, and A2 B on is a first ordered pair. More than that, we can easily see that. So it's A1 B1 and A2 B1. So we can easily see that the second element of B is at P, that's B2 is not participating. Now, again, it's a function from A to B. The function is from A to B. It simply means that in such a case, an element of set B missing is not a problem. More than that, if you look at the case by case format, you can see that each element of set A is actually having a distinct B image. I mean, a single element of set A is not having two B images. All this means that as far as the second function is concerned, we are dealing with a this is a proper function. Now let us look at another case. And let's set A and B function f3, A on A2, B on B2. So the interesting thing is that B2 is in a reverse order, and as already mentioned, such a reverse order. And when you are dealing with a function from A to B, you can't have a single ordered pair coming up in the reverse direction, which simply means that as far as the third function is concerned, it simply means that the third function is not a proper function. So let us look at the whole idea through means of two simple sets of natural numbers, that is 3, 6, 9 and B, consisting of 2, 4. So F1 has the ordered pairs 3, 6, 3, 2, 9, 4. As we can already see that 3 is an element of an element of A is having two images in two B images, and more than that, 6, which is an element of A, is not participating in the function. So it simply means that this case is this case is actually not a function. Let us look at a second case, F2, that is 3, 2 and 6, 2 and 9, 2. Here all the elements of set A are having ordered pairs in which the second component is the same, but as far as the rule is concerned, when we are dealing with a function from A to B, such a point is not wrong. The only thing is that a single element in A shouldn't be having two B images. Such a situation doesn't exist. More than that, all the elements of A are participating in the function. So it simply means that as far as the second function is concerned, we can easily see that the second function is a proper function. So this is a proper function. So that gives us the idea what kind of relations become a proper function. And so what are the key points of this particular section? The key points is that one, you should be dealing with non-void sets. That is, sets ought to have elements so that they can form proper functions. Second point is that for a proper function, all elements of set A, that is, if you are dealing with a function from A to B, then all elements of set A should participate and along with that, uh, a, I mean, an element of city should not have uh, two B as images in city as a key point. And the third one we could deal with is that here we are dealing with all the cases we dealt with functions where the sets were well defined. What if the sets are not well defined? In such a case, we deal with a real valued function as a function between sets of real numbers. Thank you.